So we've taken a look at, can we simplify powers when we are multiplying two powers together that have the same base, as well as can we simplify them when we are dividing powers that have the same base. Now, so this next one here is going to be taking a look at what happens when you put an exponent onto a power. Okay. Now, when an exponent is applied to a set of parentheses, okay, whatever is inside, okay, the parentheses, is the base of the power. Okay, so whatever's inside that parentheses is the base of the power. So in the expression that I've given here, we have 2 cubed to the power of 2, or raised to the power of 2 is how we're going to actually describe it. Okay, and in this case here, you'll notice that we have this little power on the back of the parentheses, and that's being applied to everything inside. The inside part is the base. Okay, so in the expression 2 cubed to raise to the power of 2, the exponent 2 is applied on the outside of the parentheses, or on the outside of the parentheses. When this happens, okay, we describe it as raising a power by another exponent. Okay, so if we would describe this in words, we would say 2 cubed raised to the power of 2. Okay, and that's exactly what we're going to put here in here. So 2 cubed raised to the power of 2, described in words as 2 to the, and I'm going to do it as 2 to the power of 3, a very generic one here, raised, make sure we spell that right, raised to the power of 2. Okay? It's 2 to the power of 3 raised to the power of 2. We are actually bumping it up one more time. Okay, so we are giving it a little bit of an extra boost or another exponent. Okay, now when we're using repeated multiplication to solve the power 2 to the power 3, okay, or sorry, when we're using repeated multiplication, this base or this power is used as the base. Okay, so the power is used as the base. So let's write out 2 cubed to the power of, or raised to the power of 2 in repeated multiplication. Now this might look a little bit different, okay, but that's okay. We can do that. All right, so we have 2 cubed times 2 cubed times 2 cubed. We get a 3. Okay, that's what it looks like in repeated multiplication. We're multiplying that out. Now, remember that when we have a power, we can actually write the power out as repeated multiplication. So let's simplify that into repeated multiplication again. Okay, so we're gonna actually simplify it here. Sorry, I'm gonna simplify it over here. Sorry about that. And so 2 cubed is the same as 2 times 2 times 2, and then we're multiplying by 2 times 2 times 2, and then we're multiplying it again by 2 times 2 times 2. That's a lot of 2's. Okay, sorry, I didn't want too many here. Apologies. I didn't want too many here as well. There's only 2 of them. Okay, it's 2 cubed times 2 cubed. So it's exactly like this. That makes a little more sense. Okay, to put that into a single power, you'll notice that we have 6 2's which are all being multiplied together. Even though the multiplying sign is different, we're still multiplying and it's all in one row. So it's 6 of them. So it would be 2 to the power of 6. 2 to the power of 6. And this brings us to our third and the final law that we're going to be taking a look at in this lesson here. Okay, when an exponent is applied to a base, which is inside a set of parentheses, the exponent, okay, is multiplied to the exponent or exponents, okay, and that could happen too, and we'll get into that later on, inside of the parentheses to create a simplified, and again, we're going for that simplified, a simplified power. So you'll notice here, when we have 2 cubed to the raised to the power 2, 3 times 2 is 6, okay? That's not just by chance, that is in fact the way that it is, okay? That's how it works. So let's try a couple here. Let's do a couple of examples where we're going to raise it to another power. So we have 6 cubed raised to the power of 4. Now, remember, this is 6 cubed times, times 6 cubed times 6 cubed times 6 cubed. All right, that's a lot of 6 cubes, isn't it? Okay. We can rewrite that as well, and instead of writing out the power as the base, we can actually expand each of those powers as well. And when we expand each of those powers, we get 6 times 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 6. That's a lot of sixes. Count them up. How many sixes do we have? We've got 12 of them. So if we want to put that all back into a single power, we have 12 sixes. And so this is 6 to the power of 12. 3 times 4 is 12. Okay? And that gives us our simplified power. So 6 cubed to the raised to the power of 4 is the same as 6 to the power of 12. Okay, let's try another one here. Here we have a base power of -3 to the power of 4 raised to the power of 2. Well, our base of that base, because our base is a power, is -3. So here, we're going to take -3 and we're going to raise it to a certain power. Now that power is the exponent on the outside multiplied to the exponent on the inside. 2 times 4, or 2 multiplied by 4, is 8. And so -3 to the power of 4 raised to the power of 2 is the same as -3 to the power of 8 because we multiply those two exponents together. Okay, this one looks a little bit tricky, but it's really trying to just show you that, in fact, what's inside is a power as well. 9 to the power of 1 raised to the power of 7, okay, ish, kind of, okay. We have an exponent 1 on that 9, and we have an exponent 7 outside. So that exponent 7 is going to be multiplied into the 1. 1 times 7 is just 7, so this is in fact the same as 9 to the power of 7. Okay. Again, the procedure that we're doing should make sense when we look at the final product. Okay. Final 9 to the power of 7. Yeah, it's 9 to the power of 7. We just got rid of the brackets because we multiplied it out. Okay, we multiplied that through there. Okay, last one, we're going to throw that exponent 0 in, mix it up a little bit here. Okay, here we have a base power of 6 to the power of 0 raised to the power of 3. Now we know that 6 to the power of 0 is 1, and 1 to the power of anything is just 1. Okay, so in other words, this should still be to the power of 0, and it is. Okay, you'll notice here that we have a 0 on the inside and a 3 on the outside. 0 times 3 is 0. Anything multiplied to 0 is 0. So our new power is 6 to the power of 0, which is still 1. So it doesn't actually change anything. It's just 1 to the power of 3, which is 1, and 6 to the power of 0 is 1. And yeah, so that one doesn't really change, but we're still multiplying the two exponents together to create a bigger or a simplified power.